Safety Science, Episode 6. That's bull. Bull.
Bulldog.
Bulldog. No. Yeah, that's
That happens all the time.
So, editing is a thing that can be fixed. Thank you for joining us.
duck.
I'm not even going to take a shot at what your specialty is. I know you're a post-doctoral student.
I'm a postdoctoral research associate.
Okay. But maybe you could just explain briefly sort of what your focus is and what you do.
Sure.
Bulldog.
Yes, I'm Dr. Bolduc, and I got my doctorate in biochemistry and molecular biology at Wake Forest University in Winston-Salem, North Carolina. My thesis was titled "Studies in Peroxyredoxin Hyperoxidation Sensitivity."
Oh, yeah. I've read a lot about that.
Yeah,
Say that fast.
So, a peroxyredoxin is an antioxidant that everybody has. Actually, all organisms have it except for the organism that infects ticks and is responsible for Lyme disease. That's the only exception that we know of. So all organisms across all different phyla and kingdoms have peroxyredoxins, and they're really essential in the cell to turn over hydrogen peroxide. So your cells actually create that, and as you know, that can be toxic in large amounts. And so that happens in the cell. That happens in disease states. There's too much hydrogen peroxide. There's too much reactive oxygen species. And the peroxyredoxins are really important in keeping that in the proper range, kind of like a thermostat for your cell. And so there's an interesting phenomenon, though, and it's kind of this question is that they're enzymes, and so they can be inactivated. They can become hyperoxidized, which means they just interact with too much hydrogen peroxide and then they just stop working. And so the question is why would something that shuts down right when we need it be evolutionarily conserved and propagated throughout? And so that's kind of what the field is going towards now, is to answer that question. What's the purpose for hyperoxidation? Why do these enzymes shut off? And what we found is it actually is necessary in some instances to, because the hydrogen peroxide acts as a signaling molecule. And so when it shuts down, it allows this local accumulation of hydrogen peroxide, kind of like a burst. And this is important for a couple different types of signaling events. One can be to activate cell death when a cell is not well. And so that stops it from perpetuating to a disease state. Another thing is if a cell's infected with a parasite, or it recognizes foreign DNA, like a bacterial infection or something like that, that respiratory burst can act as a way to kill off an invader. So we found out it's actually important. And then in my particular study, I found so I do structural biology, meaning I crystallize proteins and then shoot x-rays at them and try to visualize them the way that we use x-rays to visualize the bones inside of a body. And when I did that, I found out that I identified these two parts of the protein that were responsible for making the protein resistant to this inactivation. And so that's relevant in certain disease states like cancer and malaria. Those are two examples where if we could figure out how to exploit those particular regions and increase the resistance to inactivation of these proteins, we could keep them active longer. And so they would turn over hydrogen peroxide in a way that could be either depending on what we want, depending on the disease state, we could fine tune it and just kind of hijack it to work when we want it to work and to keep working when we want it to work. And so that's what I did in my graduate work. And then that led to me being recruited to work in the lab that I'm in now, which is the lab of Dr. Richard Lozer at UNC Chapel Hill. He's the director of the Thurston Arthritis Research Center. And so I'm studying peroxyredoxins in the context of aging and age-related diseases, particularly osteoarthritis. And that's what I've been working on for the past 2 years. The main takeaway from that is that peroxyredoxins are heavily involved in these kinase signaling cascades, which are responsible for initiating cartilage degradation and inflammation. And so basically they're protective, like they're soaking up that hydrogen peroxide so that it doesn't oxidize the signaling cells and affect or fuck up those signaling pathways. I hope I'm allowed to say the F word on this podcast. But if I didn't lose them like way back when. But yeah, the main thing that I've learned in the past 2 years is that if we continue to age, if we get old enough, we're all going to get sick and we're all going to die.
So you haven't worked out a way to stop that yet?
No, I mean, I don't know if you're familiar with Aubrey de Grey at all, but yeah, he postulates that aging is a disease in and of itself, and if we could stop that, like its potential, if we could stop aging, we could stop, like if we treated it like a disease, we could do that. And I mean, I in theory agree with him, and I think that like we're a long way from that, but I don't think it's impossible, especially with some of the newer technologies coming out, like in the realm of like genome editing and that sort of thing.
So you use any of the CRISPR?
That's exactly what I had in mind. The CRISPR-Cas9 system, I think, could lead to like, the reason that we age is because like the machinery we have by default is not very like efficient or effective. Like it works for 70 or 80 some years, but it over time it has an error rate that's kind of inherent, and those errors accumulate, and that's what causes us to age.
Is it the telomeres?
Telomeres. Yeah.
They get shorter and shorter.
Yeah.
And then that's bad.
Yeah, and once you on your telomeres, once you every time you divide, a little bit gets cleaved off, and once you start actually getting into the DNA, because they have like caps on them that are kind of for that, to protect the integrity of your actual DNA. But once it gets past that, it's like you start actually making errors and cleaving off parts that are responsible for, your cell upkeep. And so then it's like a double whammy. It's like you start accumulating more error, but then you're also like that error is affecting the machinery that's causing the replication. And so you just eventually break down. But if we could, with the CRISPR-Cas9, it's so much more precise and like accurate and we're moving towards that direction to where if we could like artificially kind of hack that, I think it would work.
That's our last interview. E works with the CRISPR-Cas9 to work on flies and test different genes in there. So we talked a little bit about it, but what was the Scott, the astronaut who just came back and with the twin, and they've been comparing him to his twin brother. Have you followed any of that? Because I think his telomeres came back longer.
Really?
Yeah.
Oh, I didn't know any of this. I know the astronaut you're talking about because his wife was the one that got shot, right?
I think
she was the senator.
Yeah.
Yes. Yeah, they sent him up there because he had a twin and they could compare it. But that was one of the things that I picked up on right away. Was like, wait a minute, they're longer now just because he spent this extra time in space.
Huh. I wonder if there was
whatever it was though has reverted. Didn't they say that now it's back to as it was?
I read one article one time.
Yeah.
I read one article one time.
Yeah.
But I always wonder about some of this stuff when they start talking about. I guess I approach it a little differently. For me, I'm actually happy there's an end.
Oh, totally.
I don't care to be alive forever. I think it's been 45 years, and it already feels kind of like enough.
Yeah.
But so the societal implications, though, of there is a natural process, right? So there's a birth and a death, and then you procreate and you create more. And so there's a natural cycle in there, a natural process. But I'm guessing, you guys are on the science end just looking at the mechanics of it.
Totally.
And then there's the societal piece, which maybe that's for, psychologists or philosophers or
sociologists. Economists, yeah.
But I mean, it seems to me that if we live longer, these issues with how do you keep people employed, how do you keep them fed, how do you keep them sheltered, become much bigger issues.
Yeah.
I think it encourages you to go live on another planet.
Yeah, there you go.
There's that. I think I also get a little bit like Aldous Huxley about it and like Brave New World and think like I would like to live for 80 years or 90 years, but just have a young body like the whole time. You know what I mean?
Nice.
Like, and then I'll just be like signing off. Thank you for this time.
See, that would be a good trade-off. Like I could live with dying if I could live much enjoy that life much more.
Yeah,
so
like
we have age quotas instead. So
yeah,
you can be as healthy as you want for this amount of years. And
like if they could somehow, this is all like very sci-fi at this point,
Sure.
but if they could somehow like measure your telomeres and say, oh, well, this is when you're at your peak, and so we'll just stop you there, and you'll be at your peak for the rest of that time. Like that would be kind of cool.
But who decides peak? I guess. I mean, that's
well, you do.
Because some people, I think, would consider their peak to be during their adolescence, even, or early life. And
I think if you peaked in high school, we don't need you.
well,
I'm in cellular peak, like cellular health peak.
Okay. But I mean, in terms of which cells, 'cause, I mean,
That's a good point. Yeah, I mean, because I guess, yeah, that's a good point.
Because mentally, I think you're different, and especially neurologically speaking, you're so different. Before your frontal lobe is developed,
True.
You might be at cellular peak then, but I don't know if you're as sharp as you're ever going to be. So.
Yeah.
Is it possible, hypothetically speaking, do you think, to delay aging in certain cellular groups while allowing it in others? I mean, staging it and phasing it differently?
Tissue specific type stuff. That's a really good question. I mean, ideally, yeah, because like there are some things that kind of like age faster depending on what you're exposed to. Like, for example, your liver like detoxifies everything, and so like if you live really hard, like your liver's gonna die and like age much faster. That's a kind of a funny example, but like yeah, then like I'm thinking about your brain, like that's one of the things that kind of matures later. So yeah, that's the actual approach to that. I don't know how you would do that, but that's definitely something that we always think about in therapeutic development in general, like tissue specificity.
Yeah. Well, I mean, and I guess even speaking about the brain, the way you form new memories and on a molecular cellular level, I think things are much better when you are younger because you're absorbing much more information more quickly and building memory structures and things like that. But,
yeah.
it hasn't formed a cohesive network yet. And I don't know if affecting the way your cells work together would affect the way neurological development would happen. Because if you could continue to absorb information at that accelerated rate of a baby your entire life.
Oh, man.
I mean,
whoa.
Just the consequences and implications of that on how people would think could be radically different than what we think now.
Yeah. Yeah.
I mean, this is all totally hypothetical from a non-scientist.
No, I mean, I love that. I love that idea. I think that would be really powerful. I think, yeah, it's funny that you bring up babies because I've been giving a lot of thought to that, and how the input of raw data, they don't really know how to like compute it. Sure. Basically, it's like they're seeing things and feeling things for the first time. And I was just thinking about like to see something the way a baby sees something is probably like maybe similar to how somebody on the peak of an acid trip sees things. You know what I mean? Because then at that point it's just raw data.
Yeah, decontextualized.
Yeah. And so to have that ability to absorb like you're talking about, but then also have the ability to like process. That'd be really powerful, I think.
Removing a lot of prejudice in a lot of ways, I think, because if you hadn't, to be able to simultaneously think about information in that decontextualized, unstructured way, yet apply it to everything else you'd already learned,
right,
would be remarkable. I don't know.
That's a fun hypothesis.
I think it's funny you mentioned up like, psychogenics or psychedelics. They are finding, they found this in the 60s, and now they're doing more research and finding that actually those drugs mentally can actually have physical effects as well. So, like
restructuring brain architecture, or
I don't know enough to say what it is. I know that they're doing testing now with microdoses. Mm-hmm. So what they're finding is that just giving people a little bit, not to where you're having quote unquote trips, but taking a little bit regularly actually can put the brain back into a more normal state, and then they're seeing effects physically from actually doing that.
Yeah. That's really interesting. I've been listening to a little bit about that. Not to like bring up a different podcast on your podcast, but I listened to.
We recognize there are other ones.
I listened to Duncan Trussell's Family Hour. Sometimes an ex-boyfriend introduced me to it, and he talks a lot about psychedelics. And he has like some of the researchers on there to talk about like what they actually observe. And one of the things that I remembered most strikingly was they talked about ketamine being used to like treat depression, and it causes like dendrite branching. Like they were able to actually observe that. And so like a depressed person, their dendrites, which is just a type of cell that kind of looks like a spiky ball, all those little spikes are to absorb serotonin, you know? And so like a depressed person doesn't have as many spikes as a normal person, but they treated with ketamine and saw more branching. And I was like, that's really like big, you know, to be able to like actually change the structural physiology of a cell to where it works properly through the means of a psychedelic.
Well, in structural physiology of cells, I mean, that's that's essentially what you do with looking into oxidative stress, right? I mean,
yeah,
that I think that's fascinating. The interaction of the chemicals and molecules in our environments really affect our own biology, tremendously. And what are things that you see happening in terms of regulation or things that have to do with antioxidants and oxidation? Is there anything that people should know, I guess? Like, I think there are so many things in our environment that could probably be potential stressors that we don't even realize.
Oh,
and I think that's something that if people knew more about and knew, sort of demystified the biology of it and just realized that what kind of things it can actually do to you.
Yeah. I mean, so, you know, there's like I said, there's this natural balance already in your cell. Like your cell's creating hydrogen peroxide, and then it has these systems in place to kind of keep it in balance. But there are also like peripheral sources that of oxidants and reactive oxygen species. So like pollution, that's a big one. Like cars, any type of like carbon emissions, that sort of thing, like, or not carbon emissions, excuse me, but you know what I mean? Like pollutants and stuff. That is going to increase your ROS, cigarette smoke. You know, I'm trying to think of other things. Radiation, certain types of chemo drugs, even sunlight. Like if you get a sunburn, that's going to cause, increased ROS or reactive oxygen species in your cells. So basically it's like there's no way to escape those things per se, especially not in our life right now. But I see an issue, like I get scared about this like push back against intellectualism in general and like the you know, denying climate change and that sort of thing. It's like,
that's the whole reason we have the podcast.
Yeah, it's like I get scared when I see people like pushing back against that sort of thing and saying like, we don't want to believe that's true. And it's like, well, you don't have to really believe if you don't want to, but like it's actually like affecting you, even if it's not directly, like even if you don't see the direct effects, like it's affecting your cells. And you know, it's like I worry about like the EPA regulations and like those being rolled back and like that's all like a very long extrapolation of what I do, but on, you know, on this like basic molecular biology level. But, yeah, I would say that the main thing is, exercise. It's actually really silly because it's like,
you're saying you haven't come across a pill that'll just fix all of this yet?
Not yet. We're working on it. We're trying to understand the like the fundamentals to begin with and then like go from there. But, I don't know if you've heard about resveratrol or anything, but it like extends mice life. And I don't completely remember. There's actually, it does a lot to a mouse to increase this. It like increases certain antioxidants, peroxyredoxins being one of them. Another one called superoxide dismutase is another one, catalase, all these things that it increases antioxidants. You can do that also, through your diet. Like there are certain non-enzymatic systems that help with your antioxidant capacity, like vitamin E, vitamin C, vitamin K, like all of those things you can get from your diet.
There's a lot of talk about antioxidants and free radicals and things like that in the language of cosmetics as well. And
yes.
I think sometimes people might start seeing that as pseudoscience because it's mentioned so frequently and it's like a buzzword.
Right, yeah.
Every face cream that you get is, full of antioxidants or something like that. And I don't know, I don't get angry about people using science in vain like that, but I think that it needs to be fully explained sometimes. And I don't know, maybe...
Yeah,
what do you think about
it
that?
makes me very suspicious, actually, when I see, this restaurant has an antioxidant, rich menu or something like that. I'm like, they're just going to jack up the price by $10 and it's the same hamburger as I'm getting anywhere else.
Yeah.
I don't know. It's easy to become cynical and
it's worth $10 to feel good about eating a hamburger.
There you go. But I mean, I think like so many of us are not really educated about it and, it's...
Yeah, differentiating what is real and what is just, pseudoscience buzzword kind of stuff like that is...
So I was going to ask, I'm sorry. I was going to ask about, so in the last year and a half, some of the things that have been coming down, some of that pushback you were talking about, I mean, have you seen that affect your work or your lab or your school?
Thankfully, no. One of my dear friends who's a neuroscientist at Duke, her research was specifically affected by that list of words that weren't allowed to the transgender, all those that list. Yeah, that list of words. Her stuff was directly affected, and the main effects that the scientists doing that type of work are going to see is just that there's not going to be any money for them to do their work. And it's already hard enough because there's very little money to begin with.
So we know you're going to Brussels.
Oh yeah. Yeah. So, if you don't mind, I'd like to address the thing really quick about the cosmetics. I almost went to work for L'Oreal because of that. Wow. Because of my background. Yeah. I don't like to call it expertise. It feels pretentious, but, but a lot of that stuff actually is backed by actual scientists in labs doing research about what it's doing to cells, actual tissues. And so I actually have a face mask from Philosophy that is an oxygen burst mask. And it's essentially a catalase tablet, which is a very similar antioxidant enzyme to peroxyredoxins. And it's just the protein itself dried into a little capsule. I make it into a paste, put it on my face, and then put hydrogen peroxide on top of that so that it turns it over and creates water and oxygen, and it's just poof, to my face. It's a big burst. And so it does brighten it and make it look all radiant because of that oxygen burst.
And that's something anyone can buy.
That's something anybody can buy.
You're not mixing that up in your lab yourself.
No, they sell it like that.
They sell it like that, yeah.
Okay.
Yeah, it's a brand. But a lot of the stuff is based on antioxidants and free radicals and that sort of thing. And the science is sound, but I don't know about all of the products. You know what I mean? Some of them are probably not good and are just pseudoscience. But
does any of that funding, because obviously these cosmetic companies are well funded, are they helping with research at all? Or, is it just too limited scope wise that it can't be applicable to other things?
Some big corporations are. L'Oreal gives a scholarship to postdoctoral female scientists. It's either I want to say it's 7 to 10 awards, and they don't necessarily have to be doing aging research or anything. They're just funding female scientists to try to get more women in STEM. But some of those companies who are and like I said, they hire postdocs. So you can do an industrial postdoc, instead of an academic one. And so some of them are doing that. Some of the companies, even pharma companies, I know pharma also has another, people kind of have this distrust of they're just jacking up prices and making money off of us. But not all of them, you know what I mean? Some of them are actually trying to get back to science. But yeah, I'm going to Brussels. So I've been at this postdoc that I'm at for 2 years, and I go to this international conference every other year. It's a Gordon conference, which is they have these for all kinds of different science. And I go to this specific one that's thiol-based redox signaling and regulation, which is a title that just encompasses all of what I just told you about my work. That's
so like the 20 of you in the world can get together.
The 20 of us. It's actually pretty big. It's like, well, it's big for Gordon. I think it's like, it is kind of like nerd summer camp. And we just all kind of get together and they're like, oh my God, tell me about your work. What have you been doing this past year? And we get really excited. But, so I've gone to this. My first one was in Spain, and that was the first time I'd ever gone out of the country. Like, I'm just this little girl from the trailer park. Like, I'm the first in my family to go to college. Never been out of the country before. I went to Spain, and I was just like, oh my God, this is amazing. This is beautiful. And I met like all these international scientists who were just like fucking cool and like eccentric and like they all had accents, and I was just like, oh my God.
You have an accent.
I do have an accent. They're like, we're like drinking wine and we're talking science, and I'm just like, oh my God, this is like the best. I feel so cool. And I met this person who's now going to be my new boss at that first one, and he was like really engaged in the parts that were just for graduate students and postdocs. Like you could tell that he really valued mentorship and just like encouraging people in their ideas. And he was just so kind. And, you know, there's a lot of ego in science, so not everybody's like that. And I was really excited to be there because, like, I felt like I could finally ask a lot of questions and get a lot of feedback. I don't know. It was very stimulating and enriching. And so then I saw him the next time. And at the next time I got nominated to plan the one that's coming up this year. And so then recently, Joris, that's my new boss, he emailed me and was like, hey, is it okay if group leaders, meaning himself, is it okay if we come to the part that's for postdocs and graduate students? And he's come to that one like every year. So I was like, he already knows the answer to this. And I was like, maybe there's a change to the policy or something? I should check on it. But there wasn't. And so I just responded and I was like, of course, Joris, we would love to have you. Like, look forward to seeing you. Can't wait to catch up. And then he was like, oh, by the way, I have this opportunity for a postdoc. Are you interested? And I was like, well, I am currently postdocing in North Carolina, but tell me more about it. Like, what is it? And, when would you want this person to start? And he responded back and he was like, here's the description for the thing. And he was like, I think you're a really good fit for it. I want the person to start tomorrow. Let's talk on Friday. Send me your CV. And I was like, okay. So that was on a Monday. Talked to him on Friday. And then the following Monday, this was like a month ago. The following Monday, he was like, I want you to come. He was like, and then he wrote this like really kind letter. It was like a motivation letter to the committee at his institution. Like he had to justify why he wanted to hire me. And he was like, I remember from the first Gordon conference, Jes set herself apart from all the other postdocs by the questions that she asked and how engaged she was in the meeting. And like, he remembered me from that. And so it was like this weird full circle thing. And yeah, now I'm going to Brussels and I'm going to be there for at least 3 years.
Yeah, I only brought that up because of the pushback, in the U.S. And then you just happen to get this opportunity to be outside the U.S.
I'm very excited.
Likely in a place that thinks highly of that type of research. So.
Yeah. It does feel kind of like, it all feels very serendipitous just because I'm like, things are getting really crazy right now in the U.S., but I don't really want to talk about that too much because I'm afraid that my visa will get declined if I talk about it too much.
Well, what about mentorship? Do you find that there is a real dearth of that in, your field or others specifically? Or is that something that, how do people encourage that, I guess? Because I think that's crucial.
Absolutely. Also, if I'm talking too much, tell me. I just get really fired up about this. So mentorship, I've been really fortunate. Like my graduate advisor, was a family man. So he was really understanding and accommodating to my life and like me having a son and also being in science. Some people expect it to be your entire life and like you have to be in the lab constantly. And there's not a lot of mentorship. They just expect you to figure it out. In fact, there are like studies about graduate student depression and like mental illness and that sort of thing. And the numbers are dismal. Like it can be really stressful. It pushes you to your limit. But like I said, I've been really fortunate to have like this really good pedigree of mentors. And I think it'll continue. And then like recently I've started mentoring people myself as a postdoc. I like trained. I'm training an undergraduate now, and then I had a summer student through the solar program. She's applying to graduate school, I think now, actually. I think she's trying to do an MD PhD. So like it's really important. Not a lot of emphasis is put on it, but I think it needs to be. It needs to be something more discussed, and it also needs to be fostered a little bit more, because I know plenty of my other friends in graduate school had some bad mentorship experiences where people were like physically aggressive towards them, or like, you know, like actual HR problems. And I think it's just because it's such a stressful field, and like people don't really know. There's not a lot of emphasis on coping and interpersonal skills, but there should be.
I can say, so, you know, I've been in technology for a long time.
Yeah.
And I didn't come from the trailer park. I came from Boston. It was basically trailer park triple deckers. But one of the things that turns me off, I don't know if it's the same, but, you know, there's a few really good, what I would say are really good mentors in the area as far as the entrepreneurial scene.
Yeah.
Ken and Hillary are very heavily involved in that. I've become a little bit more involved lately. But there's a ton of people that say they're mentors, but really if you don't have something that's going to produce money or put them in a good light in some way, they don't really care.
Yeah.
So that's a bit of a problem, I think. I've been trying to think about ways to connect people with entrepreneurial sort of spirit directly to build, you know, I think of it in a music sense of, you know, it's never the top pulling those creatives up. It's the group getting together and building something that can then bring everyone up at the same time.
Yeah.
And I don't know if that's the same in the scientific community or not, but you know, it's definitely in the entrepreneurial side. I've seen it with art and with business.
Yeah, I'd agree. I mean, I think we were talking about this a little bit earlier before we started recording, but like some mentors, some principal investigators that run a lab will be hesitant to take on a woman postdoc because they might think she's about to start a family, and that will pull away from her contribution to the lab. But, you know, I think in science we have to shift that. We have to shift that type of attitude, because it's like we need representation of all different people in science, in every field, really. I get a little like philosophical at this point about this sort of thing, but I think everybody has a contribution to make because we all think differently. And science isn't this thing that necessarily even requires intellect. I think it requires creativity more than intellect. And so somebody from a different background and a different perspective has a key, like essential contribution, however small it may be. And we have to like give everybody their time and listen to them. And so to run people off because they want to have a family, or to run people off because they don't talk the way we do, or they don't wear tweed jackets with fucking elbow patches on them, they're not, you know, old white men. It's like we can't do that anymore if we want science to progress.
What about interdisciplinary collaboration? Is there a lot of that in your field scientifically, or I mean, is that something? I wouldn't know where to go as an entrepreneur to collaborate with scientists. Yet I see a lot of things going on, especially with biotech in this area. People bringing their ideas to an entrepreneurial scene and trying to take a route other than using big pharma to develop their ideas, or with medical products like devices.
Yeah.
And I don't know. I just think that there's so much to be learned from one another.
Absolutely. I agree with that really heavily. I actually did a technology commercialization internship at Wake Forest Innovations. Mm-hmm. And that's kind of that whole field is saying, like, we're going to partner with academics and say, we want to help you make your discoveries and your new developments profitable, not just for us, but like we're going to generate money to where we can use some of that money to give to you to fund your research, and then also to pour back into more innovative like discoveries in other labs and in our like little network of our institution. And so like that's this new thing that's kind of like budding. I think it's not really new, but it's like getting more attention and more investment. And that's like an alternative to not only pharma money, but also like government money, like the granting agencies, which are so tight right now.
Yeah. I think finding ways to circumvent that and innovate around it is really critical at this point in history. So,
yeah.
I've been writing an article in my head. You mentioned, the importance of creativity, and to me, creativity is not optional.
I agree.
I think that if you're not doing something creative, to put it bluntly, you're wasting everyone's time.
I agree.
So, we, even though I'm a tech computer guy, blah, 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 I played in bands forever. We just had a show here last night to try and raise some money for our friends for the March for Science.
Cool.
I never feel better than when I'm in a room with creative individuals.
Yeah.
I can be in a room with I've met the people that run Dell computers. I've met people in these big corporations. I can't stand talking to them for more than a few minutes.
Yeah.
I find it completely and utterly boring.
Yeah.
And so I know, you bring a creative side to science, but I also know that we're SoundCloud buddies.
We are.
You've been doing garage band music and stuff like that. So how does that... Did you come up doing art? Or is this something that you kind of just came to?
I didn't grow up doing art. I didn't come up doing art. I think I started getting into like performance art. I did drama in church when I was a teenager. That was kind of the start of it. But I would have like these, not like visions, but like creative ideas about almost like music videos to different songs. And I'd be like, let's make these happen. And so me and my little friends would make stuff like that. But, and then in college, like I majored in chemistry and minored in biology and then tried to do a minor in theater, ran out of time and had a disagreement with the director of the theater because he called me, he said that I looked bad in a unitard, but that's another story.
Who looks good in a unitard?
I know. I was like, it's a unitard. But anyway, so like I've always had this creative side, but that's what I really like about the structural biology is because like the visualization of these proteins, one of the artists that made it, the original like standardization of it is at Duke. Her name's Jan, but I can't remember her last name. I want to say it's Robertson. Her and her husband are like this dynamic duo in structural biology, and she's an artist. And so the way that we visualize proteins, we have things called like ribbon diagrams, and like there's like beta barrels, and like it's all very standardized, but it's very artistic and really beautiful. And so like I really like doing that now because there is like a certain art to it. And even like making the crystals and seeing the crystals, like that's all very beautiful and like inspiring and stuff. And that part is very much an art. Like it's just kind of luck of the draw. You make these screen tray, like you screen a bunch of different conditions and you don't know whether you're going to get crystals or not. Once you get crystals, then you go and you do your work, and that's all very scientific. But like the crystal making is kind of like a magic part. You know what I mean? But then recently, so in graduate school, I got involved in stand-up comedy, and that was like I kept it very separate. Like, I didn't really talk about science or being a scientist very much, like on stage. If I did, it was like kind of like the butt of the joke was like, "Can you believe it? I'm a scientist." Because I would like point out how dumb I am. But, it's just been something that I think it's important because it clears the pipes, you know, like even if what I'm creating is shit and it's not what I want it to be or whatever, it's still like I'm moving things out of me, you know, I'm expelling these things that can clog the pipes and keep those good scientific ideas from coming to the forefront and coming out. That's how I look at it. It's just like, it's a matter of movement.
It's just like your face mask.
But yeah. Yeah, exactly. I gotta slow off the dead skin to get the new skin.
And how awesome, we talked about this a couple of times. We actually interviewed Mannheim for his Norwegian black metal guy I used to listen to when I was a kid. So we brought it up a couple of times, but how awesome is it, talking about science and technology, to live in a place where you can sit in your kitchen with an iPad and literally produce something that rivals what would come out of a studio.
Yeah, that's super cool.
In 20 minutes,
Yeah, I think that, and I love that. I think it's cool to just say, like, to give yourself permission and say, yeah, this is a different way, but, it's 2018 and we're moving forward, and I don't necessarily have to know how to play an instrument in order to be an artist or a creator. Like, there are less hurdles to be creative. And I think that's going to allow kind of this influx of good art, because more people will say, hey, it's accessible to me. I can do this. Like, so what?
Have you ever done visualizations of some of these crystals and things and done it as in like an art print or something like that?
I have thought about that, actually. And I also thought about getting the part of the structure that I solved. I thought about getting that tattooed on me because it's just cool. But it's not something I've done yet. But there are some really beautiful photos I could even send you from just captured of my crystals, and they're like in my presentations and stuff.
That'd be cool.
Yeah. And also, on that note of like creativity being necessary and not optional, like in science, there are some people who are really intelligent and like could be brilliant scientists, but they're so stuck on like, this is the protocol. This is how we have to do it. If there is no protocol, we can't do it. And that lack of creativity really holds them back from being like a legend.
And it'll stop progressive forward movement as well.
Yeah.
I always bring it up, and I wish I could remember who said it. I didn't think of it. I heard it somewhere, but somebody said, there's all these good ideas out there, and it's not a question of needing the right people to actually promote those ideas or those new processes. You actually have to wait for the old guard to die.
Yeah.
So that the younger generation can come up and then take over.
I mean, I think we're seeing that now, too.
It's a sad state.
Yeah.
It's a sad statement. So.
Cool. Anyone have any questions?
So people, do you give out your SoundCloud, and are there places where people should go find you? Are there links that you want us to put on our website when we launch this?
I would,
or should we wait till your visa process?
Oh, that's what I was gonna say. There's one more thing that I do called the Traumedy Show, and I would, I would actually encourage people to check that out more than my personal stuff, because I'm actually trying to like phase all of that out.
Yeah.
I don't want to be a part of social media anymore. I feel like it's a disease, and I feel like it's a monster we've all helped create, and it's going to get out of hand.
Zuckerberg does have approval process of your visa.
Pardon?
Zuckerberg does have approval process of your visa.
We're actually going to start calling it a Azusa.
Azusa. Oh man. So yeah, I would urge people to keep up with the Traumedy Show. It's Traumedy. It's a show that I co-produce with my best friend Russell Davis. He's going to kind of take over a little bit while I move to Brussels and get settled. But then after I'm settled, we're going to be doing some more online stuff to where I'll still be involved. But the Traumedy Show is just a comedy show all about bad stuff. It's performers who are both comedians and storytellers talking about the worst things that they've ever been through, but with humor. And the emphasis is on resilience and healing and like just being a survivor. And, we're trying to amplify voices and encourage people to not be afraid of talking about their secret shame or the things that they've been through, because we've all been through bad stuff. And the point is we made it out and we are still here. And so we raise money. The shows are always free, and we raise money for different trauma resources locally, usually the Orange County Rape Crisis Center. We've also donated to Our Voice in Asheville, and I forget where else, a couple other places. But we've recently switched to an online format where we're going to start doing a talk show where we just interview people, basically. It's like a podcast, but you get to see us. And talking to people all over the country. So the first one that we did, we talked to somebody from Connecticut, Indiana, and Boston all in one night, which was cool. And so it ended up reaching like 2,000 people. Like we got 2,000 views in 24 hours. And it's just like, this is the age of the internet. Why aren't we doing more stuff like that? Like, I want to talk to people all across the country, So check us out on on Facebook, The Traumedy Show. We also have an Instagram called The Traumedy Show, at The Traumedy Show. And you can pretty much keep up with me on there. My personal Instagram is private, but if you want to follow me, I'll maybe add you at my discretion. It's Infinite Jes, infinite.Jes with one S. That's pretty much it.
Well, if you want to move from the internet to the basement, I know we talked about it, but before you leave...
That sounds very scary.
Before you leave the Brussels, if you want to do something here.
Have a Traumedy Show here, yeah.